All right, does that sound okay back there? Can everybody hear me? If not, I'll just start yelling, so make sure you let me know if you can't hear me for some reason. Again, my name is Cory Minton. I'm a principal systems engineer for EMC, which just basically means I'm a huge geek, and they let me run a team of SCs around the world that are really excited about Splunk and some other analytics capabilities. So what I'm here to talk to you today about is what EMC is doing with Splunk. As Simon mentioned, we're doing a lot of validation and testing to make sure that at the end of the day, our goal is to make your lives easier and your customers' lives easier to deliver and deploy Splunk at scale. So some of the trends that we're seeing from a Splunk perspective is that Splunk has become a truly business critical application. It's no longer in the dark corners of our customers, right? Yeah, there's still some of those that are still wearing hoodies in the corner playing with Splunk, but for the most part, a lot of Splunk customers have gotten very much enterprise scale, right, using Splunk in a variety of ways that are beyond just the traditional sort of log aggregation, right, into security, into business analytics. And so because that scope is increasing, we're seeing the size of Splunk deployments increase pretty rapidly as well, right? The amount of capacity being indexed per day and the amount of retention that customers are having to keep based on the fact that they're looking at data sets that may have regulatory compliance requirements around them. So it's also, because it's a critical application, it's coming under the guise of enterprise IT standards, which means you have to implement things like high availability, disaster recovery. And so we think that the underlying infrastructure is becoming pretty important, but it's also because it's, enterprise IT is starting to care about Splunk as a business critical application. IT is starting to want to own some of the infrastructure. And so the times where customers would just deploy on a few servers in the corner are starting to change in some of the larger Splunk deployments. And then a lot of the large scale customers, right, the north of a terabyte, 2, 3, 4 terabyte sort of ingest per day customers, efficiency at scale is becoming kind of a challenge based on the efficiency of storage and having that much capacity on hand at any given time. So EMC, as a general statement, we're committed to providing scalable and incredibly efficient Splunk solutions, okay? So I always like to start with this from a design perspective that you probably know EMC, and EMC has lots of products. We're a portfolio company. They've got products that overlap with each other, and I don't want to confuse anyone about that. But I want you to understand we, as a company, are trying to partner with Splunk around some specific platforms that have a design paradigm that is similar. So Splunk, as you know, they start as small as can run on your laptop, all the way to running on thousands of machines, right? That's what we refer to as a highly parallel scale-out application, right? It scales linearly as you add resources to it. So EMC has some storage platforms that don't abide by that design methodology, which is our traditional sort of monolithic storage arrays. And then we have a number of technologies that are very much scale out in nature. They're designed to linearly scale both performance and capacity as you add resources. So you'll hear us talk about a few technologies from EMC specifically that follow this design paradigm. They're not monolithic arrays where as they get kind of full, they start to fall over. They're very much scale out in that you can start small and scale to potentially thousands of machines participating, okay? All right, so most of you probably are aware that Splunk from an indexing perspective, and remember, indexers are the ones that do the heavy lifting, they're the ones that need the most I/O, right? These are the big bad boys in the Splunk environment. You probably heard during the architecture session that if you have performance challenges, start by adding indexers, and you'd think that you'd add search heads, but realistically, indexers have a bigger impact on performance. So Splunk does a nice job of tiering the data based on its aging or size and volumes, right? So you guys are familiar with the concept of hot, warm, cold, and frozen. The interesting thing is hot and warm, again, you want that to be really, really fast because that's where most of your searches are going to happen. As they said during the architecture session, they did a survey of all Splunk customers, and they found that 98% of searches hit data that's 7 days or younger, right? It's only been in the environment for a short period of time. So in these environments where hot and warm, it gets real interesting to start to look at really high performance technologies like Flash and some other really high performance environments. Okay, so that's cool. But on the cold side, cold is where you keep the data for longer term retention periods, typically north of 90 days, maybe a year, maybe 5 years, depending upon the organization that you're supporting. Now, trying to do 5 years retention with all flash technology will be very, very expensive. Trying to do it with servers, just with direct attached storage, will get very, very large in the number of servers you'll need. So what Splunk does is on the cold path, they allow you to use network attached storage as another option. And network attached storage, as many of you know, is oftentimes much cheaper from a cost per terabyte perspective. So that's kind of interesting. And then frozen, is the concept of putting data out of band, right? It's no longer searchable if it's in frozen, right? It's off. And some customers use that purely for regulatory requirements, right? They have to prove that they've kept 3 or 5 years of, let's say, security data. But we generally don't like frozen because that means that your customers and you aren't getting value from that Splunk data. It's out of band. You can no longer search it. And if we know anything about statistics, right, as you increase your sample size, your likelihood for accuracy improves estimating populations, right? So have more data, do more searches. They're more interesting. Okay, so oftentimes customers ask, and even partners and Splunk SEs, always like, well, how much storage do we need, right? How much, when you say you need storage for Splunk, we all know that, duh, right? But how much does it actually need? So I think this is kind of interesting. So let's use a terabyte per day ingest as an example. So Splunk is pretty good at doing some compression, and when it writes data to disk, it does a pretty nice job of reducing the overall footprint. So in general, right, and there's obviously lots of levers you can pull that would change this, but in general, a terabyte of data ingested is about 500 gigabytes on disk. And that's split up into 2 sets of data, the first of which is your raw data, that's your compressed raw data, right, your GZ files, and then your indexes are the good GUI bits. That's the part that Splunk actually uses and that we want to take care of because it allows the indexers to provide search results. So in that 500 gig, about 150 gigs or so will be the raw, and about 350 gigs will be the uncompressed indexes, okay? So then you kind of have 2 questions you have to ask when calculating storage for Splunk. It's, well, one is ingestion rate, which we've got at a terabyte. The next is retention, right? It's pretty simple math. I don't want to blow anybody's minds. Okay, so it's a terabyte times a half, and let's say our retention is 60 days. Well, that's pretty simple math. It's about 30 terabytes. Does everybody agree with that? It's pretty accurate? Okay, so 30 terabytes, 9 terabytes is my raw data, and 20 terabytes is indexes. That doesn't seem like a lot, but here's the deal. As you start to turn on things like, again, those high availability features that many enterprise customers are asking for, that starts to get compounded, right? So the way Splunk handles indexer clustering are 2 settings, one called search factor, one's called rep factor. Search factor handles the number of times we copy the indexes to other indexers, and rep factor handles the number of times we copy the raw data. Some people argue best practices. We typically see about a reference, or the kind of normal customers do an SF and RF of 2 when they start. Sometimes they'll jack one of those, so they'll jack RF to 3, but in general about 2. So if you jack it to 2, right, if you make that setting go to 2, for the purpose of that high availability of those indexes, you've officially doubled your storage requirements. If you turn it to 3, it's really complicated math. You've tripled your storage requirements. So this efficiency problem, although it does provide that high availability, it does challenge from a storage efficiency perspective. Okay, so this is why we think one of our general premises from an EMC perspective, and we're seeing large-scale Splunk customers think about, is decoupling compute from storage. And the concept here is that if I'm a small environment, I'm not keeping data very long, servers with direct attached disk is fine. But what happens if I'm let's say a 2 terabyte customer, which is not a terribly large customer in Splunk terms these days, and what happens if I have a retention period of, let's say, 5 years? That's 3.6 petabytes of storage required. Petabytes. Now, I know that's not a term most folks are really comfortable with, but it's becoming very germane in a lot of the big environments and big analytics environments. Petabytes are normal. But 3.6 petabytes, trying to get there with servers and direct attached disk, kind of painful, right? Very few customers will actually have the need, if they're only ingesting 2 terabytes a day, they don't need 3,000 indexers to do it, right? You see the point where I'm making? Okay, so what we want to do is help you decouple compute from storage so that when you make investments in infrastructure to support Splunk, you make the right investments, right? If you need more compute horsepower because you're CPU and memory bound based on your search load, add more CPU and memory. If you're bound because your hot and warm isn't fast enough, add high performance technologies for your hot and warm tier. And if you're just trying to keep data for longer from a cold perspective, add a tier of storage that's optimized for that cost per terabyte that you want to achieve, okay? So some of the reasons why EMC we think we're kind of awesome in Splunk land, and obviously I'm paid for them, which is why I would say we're awesome, is that we actually have some storage platforms that are really nicely designed to fit Splunk's use cases. So for hot and warm, we have 2 scale-out technologies we like to talk about. The first of which is an all-flash array called Extreme IO, and this is every year is the year of something. Like 2014 was the year of VDI. Now it's the year of all-flash and storage. Okay, so it's an all-flash storage array. It's really awesome. Does some interesting things we'll talk about. Scale IO is a software-defined storage strategy, and we'll talk about that in a little bit more detail. But these 2 are really great for that hot and warm because they both provide SAN or high performance, low latency access for hot and warm data, okay? And then from a cold perspective, or even if you do have frozen, which we would want you to avoid, but if you do have it by chance, Isilon is a scale out network attached storage environment that's really, really interesting. Now, why would you use shared storage? Well, you'd use shared storage because, again, decoupling compute from storage allows us to scale capacity or performance distinctly when we need it, okay? Now, storage platforms are interesting for Splunk because they can add some real value. The first of which is if you're looking at Extreme I/O, it has deduplication built in inline. So all those copies of data that I implemented when I did RF and SF of 2, they're completely canceled out by the deduplication, thereby decreasing the amount of storage consumption and the amount of storage and space I take up in a data center. Isilon, very much the same. We also provide snapshots. If you provide services to companies where they have things like requirements for data at rest encryption, which is becoming more and more common these days, all of these hardware platforms provide data at rest encryption, which is pretty interesting. And there's some other data space saving things like compression and deduplication, but really the big story here is that it's efficient and it's designed to decouple the compute from storage so that you scale nicely. Okay, so again, Extreme I/O all-flash appliance, scale out. You can start with one brick as small as 5 terabytes in capacity and scale all the way to 8 bricks with 320 terabytes of capacity. Each brick is roughly 150,000 I/O capable. That's a lot of I/O, right? And it's aggregate, so we connect these things together using this ultra-fast low latency network called InfiniBand so that you actually get linear scale. As you add another brick, you add another 150,000 I/O, you add additional capacity. So very much linear in its scale. So again, if we can go to 320 terabytes, I can handle 7 days of some pretty large customers from a deployment perspective for ingest of hot and warm, right? And again, the deduplication is really the big story here. Right, having somebody who has indexer clustering turned on, this is a really interesting platform because again, it cancels out the overhead. It's as if they didn't have indexer clustering turned on from a storage consumption perspective. So where we play here is, again, if they have indexer clustering, kind of interesting. If they haven't invested in flash technologies and are looking to accelerate the performance, this is a really interesting platform. It's also interesting if they already have Extreme I/O, that this is just, you could throw Splunk on it as well. We really like additive use cases. And you'll find that there's a lot of customers that have Extreme I/O out there. It's the most widely sold all-flash array on the planet. Okay, now Scale I/O is slightly different. It is a software-based, software-defined storage strategy. Think about it this way. If you've got servers that have some drives in them, we can basically abstract those drives from being directly attached to that particular server and create a virtualized SAN environment across all those disks, aggregating the capacity and performance of those internal drives. Now that's kind of interesting where customers maybe already have a large investment in commodity hardware, but they want to add some feature sets like encryption and security and snapshots and data services that Splunk doesn't do natively. So there's the largest bank in the US has actually deployed this, deployed Splunk on Scale I/O. Because some customers will have a software-defined strategy. They don't want to buy storage appliances from people like EMC anymore. But it turns out we're pretty good at software too, and this thing's called Scale I/O, and they really like it, okay? Oh, I didn't kill the timing. Jump the gun. Here's Isilon. Hey, so Isilon is a scale-out NAS platform that's, again, designed that same way, right? You can start with as small as 3 nodes, which is roughly about 20 terabytes, all the way up to our scale, which is 144 nodes today, and that's 68 petabytes in a single volume, single file system, single namespace. Literally, it's a drive letter. Like you can map it to your laptop and you can see 68 petabytes of space. It's crazy. But it's really interesting because, again, as you start, customers may start small and they may say, oh, I've only got 100 terabytes that I need for cold. Great. Isilon can start at 100 terabytes, but as they grow or as their retention period increases, you just simply add nodes to the cluster. And it's much like other scale-out platforms. Every time you add a node, you're not only adding the capacity to the storage, you're also adding performance to the storage. So everything gets better as we scale, okay? It's also interesting because from a cost per terabyte perspective, once we get over that sort of 100 terabyte mark, it's one of the most competitive storage platforms on the planet from a cost per terabyte perspective, okay? So again, it also has deduplication. Now it's not inline deduplication, it's actually post-process, which means that the data gets written to the disk and then there's a job that gets scheduled to run to go deduplicate things. We don't account for that in our sizing. Like if you were to come to me and say, hey, we want to build an architecture, I wouldn't assume any savings from the dedupe, but I can tell you that the mileage will vary, but it's roughly about 20 to 30% on average, and it increases significantly if they're doing indexer clustering, okay? All right, so those are cool storage platforms, but we would be really uncool if we didn't do a job of testing these storage platforms working together. So taking Extreme I/O and Isilon, putting some compute in front of it and running Splunk on it, see if it actually does what we say it does. Turns out it does. We've got these reference architectures to prove it. So Extreme I/O and Isilon, or Scale I/O and Isilon, should you want to go that path. Reference architectures, and again, you all will get these slides, so there's links here where you can go grab those. And Splunk has actually gone into the lab with us, tested this, and proven that it does absolutely meet or exceed the published reference architecture performance specs, okay? Now, if you don't really just like talking about storage and you don't want a reference architecture, you want a cloud-like experience that a customer has on-premise requirements, then we have an organization at EMC called VCE. So the Virtual Computing Environment was actually a company launched about 6.5 years ago. That's a joint venture between EMC, Cisco, VMware, and Intel. Right? Some big names, some big powerhouses, right? And the goal of that company was actually to go out and do something that customers asked us to do, and that was, I don't want to integrate servers, network, and storage, and then have to do all this VMware stuff. I just want to buy an appliance that's integrated from the factory, and I have one number to call for support. That's what this is. So again, cloud-like, it's a single platform that integrates the EMC storage that we've talked about before, right? We can help you figure out which one is right, but at the end of the day, we build these things in the factory, and it has your servers, network, storage designed specifically for Splunk requirements, and it's literally one number for support, and it's a single update for the entire stack. So really cool packaging for, again, if you buy into the value props of EMC, this just takes Cisco Compute and puts it in front of it, and it's really, really slick, okay? Now, we also have been making some significant investments, not only in, hey, we have some products that are cool for Splunk, but we've actually been going out and trying to be a better Splunk partner in that we have applications that if you have Splunk customers that also have EMC technologies in-house and you'd like to Splunk them, here you go, right? We have applications, right? VNX, right, the one at the bottom, that is the most widely deployed storage array on the planet. I can't remember how many tens of thousands. There's something like, I think there's like 80,000 VNXs around the world, okay? We have an application to where if you'd like to Splunk some of those 80,000 VNXs and start to index that data, there's an application and a TA available. Same thing for Isilon and for XtremIO as well. And then Isilon, actually, we just recently jointly developed, actually an SC from Splunk named Simon O'Brien and an SC from my team in Brisbane, Australia, jointly developed this Isilon file system auditing application. Now this is kind of interesting because if you have Isilon deployed at a customer for, let's say, their home directories, right, for all their network file shares, you can actually Splunk and audit the file system access, so who touched what, when, and from what location. So very interesting from an auditing perspective. And again, these are just investments we're trying to make so that Splunk can derive value and Splunk customers can derive value from their existing EMC investments. And none of these are paid for, they're all free apps today. Cool? And the XtremIO and Isilon one, we outsourced, we paid somebody to build. The other ones have actually been built internally, so we're getting smarter. Okay, now, we size Splunk infrastructure, hopefully the exact same way Splunk would do it themselves. Because when an application vendor and a hardware vendor disagree on something, the application vendor's opinion generally wins. And we don't want to be the guys that put Splunk customers in a bad spot where we're like, no, Splunk's wrong, they don't know how to deploy hardware. No, we know they do, right? So why would we try to argue with them? So what we do is I've got 36 folks around the globe that are, have been trained as Splunk SCs. Most of them, actually all of them have been through SC1, some through SC2, and then they've got a few that have actually gone through SC3. We actually have services folks that are actually going through the consultant track. And so we try really, really hard to learn the best practices. That's why our folks are here. That's why we were in Atlanta for the Americas last week. That's why we'll be in Malaysia later this year to learn what you guys learned so that we're all on the same page, okay? And then we also have, so these ninjas, I'd highly encourage you. We literally have them in every geography. There's 6 of them here in Europe. If you have EMC shared customers and you don't know your local ninja, please find me and I will tell you who your ninja is and hook you up with them because they're pretty cool folks. All right? And then if y'all haven't seen this is kind of interesting. We like this thing. I know it's not officially supported, but that's an interesting Splunk sizing app. If y'all haven't played with it, it really gives you some nice storage numbers. Okay, so why in the world is EMC partnering with Splunk? Well, because it's good for everybody, right? It's good for our customers because they get this enhanced integration, right? If we're doing things like converged infrastructure and having Splunk tested and prove that it works, it simplifies the deployment. For our partners like yourselves, it's great because you can focus on the Splunk deployment and not worry about making sure that the underlying infrastructure will actually do what it says it'll do, right? We design it to best practices, deploy it quickly so they get, again, that cloud-like experience in an on-prem model where it makes sense. And then Splunk gets access to some really interesting resources. We have a lot of salespeople. EMC is a big selling machine. I know it's surprising, right? I'm up here selling to you, and I'm not a sales guy, just so we're clear. I am the engineer, as I said. But we have a giant sales force that's really good. So think about how great it is for Splunk to have that many more people out there talking about Splunk. And so our resources, our salespeople, can actually now sell Splunk to customers. Now that's kind of an interesting one because if you run into an account where Splunk is not already installed, it's sometimes challenging just to get new vendors added to a purchasing department's sort of process. But if they already have EMC, they can acquire those licenses through EMC in a very low friction way that it doesn't affect Splunk. Like they still make their money, we make our money, it's all great, everybody wins, but it may be simpler for the customer, okay? And then EMC technologies are getting smarter using Splunk. And then obviously like our pre-sales teams are getting smarter. I actually have a hackathon scheduled later this year where we're actually going to turn our Splunk Ninjas loose on some of the most pressing problems for our internal SCs. Like what are the biggest challenges at getting data out of our customer environments and how do we Splunk that data and provide real-time intelligence back to our field resources. And then collaboration just drives innovation. So if we're working together with partners, with customers, and Splunk and EMC come together, we've got a great number of resources that everything will continue to innovate. And that's pretty cool. And we are committed to your success. So again, if you have questions, I'll have cards up here for anybody that wants them. Now, as Simon said, we've been working together for about 8 or 9 months. Officially, EMC and Splunk created this strategic alliance about 6 months ago. And here's some of the things that we learned. There are already a lot of Splunk customers that have Splunk deployed on EMC, and some we didn't even know about. Like we were actually quite surprised when we started to do some introspection into like our Salesforce and install base records. We're like, oh my gosh, like there's some really big Splunk customers running on VMAX or running on VNX and traditional storage arrays. And that's good. The thing I would say is that we're also finding out that there are a lot of levers you can pull when you deploy Splunk that can have a massive impact on the infrastructure under the covers. And so just make sure that when you make changes to your Splunk environment, whether it's index, it's retention periods, it's data model acceleration, right? Any of these things, they do have underlying infrastructure impact. So make sure that you're thinking through those before you just go pull that lever because it may create challenges for you in hardware. Be careful with the benchmarking with Bonnie++. Just so everybody's clear, Bonnie++ is not an accurate representation of hardware performance in a shared storage environment. It's known, Splunk folks will tell you, the Splunk engineers will tell you, it's not an accurate reflector. We actually had a customer that was testing Isilon in this case for cold, and even though there's no published like metric of how fast or latency or anything else like that, they did a Bonnie++ test with it, and they were getting like 17 seconds latency against the Isilon. But when they actually deployed Splunk and they reran it they reran some testing on latency, not using Bonnie, it was sub-millisecond. And it was literally just because the testing tool wasn't accurately reflecting performance. So just be careful. The other thing is like depending upon which version of Bonnie you run, you will get very different results. So just be careful with those. The story there is if you have questions about EMC hardware appropriately supporting Splunk requirements, ask your Splunk SE, ask one of the EMC folks, and they will help you validate that it's absolutely configured correctly. And if it's not, we'll help you fix the problem, okay? And then we collectively, EMC and Splunk, don't know as much today as we'd like to about Splunk performance at scale on shared infrastructure. So one of the things that this kind of last tagline here talks about is some joint EMC and Splunk resources have embarked on a pretty massive data collection project. And so basically what we're going out and doing is we're trying to target about 50 customers globally who have EMC currently supporting their Splunk environment. And we're doing some data collections using our traditional SC and performance validation tools, as well as Splunk, right? We're using SOS and some other tools to grab Splunk data to build a profile of what Splunk looks like at various scales on various hardware platforms. So we can do a couple of things. One, improve our reference architectures. Two, build benchmarking tools that do accurately represent performance and that will give you a real clear understanding, not just from an EMC storage perspective, but if somebody's running some other SAN, that you actually have a benchmarking tool that would be really useful and indicative of what real performance would look like, okay? And so we're hoping to have that all done by Conf. We actually have a session approved for Conf about IO profiling, so we have a kind of a timetable, and we're gonna look like, have pie on our face when we get to Orlando this year. Okay, so my asks of you, again, don't want to take too much of the time today, but get to know me and my team of ninjas, right? I'll be around. If you don't know who your local ninja is, feel free to shoot me an email. We would love to introduce you to those folks, especially where you have joint customers. So if you have accounts that are both EMC or Splunk, or they're EMC accounts looking to deploy Splunk that you think you would be helpful in deploying that, then certainly reach out to us or take us into those accounts and we'll absolutely help you. Just to be clear, we actually don't have any professional services offerings from EMC today relative to Splunk deployments, and I'm looking in each theater for partners that can help me deploy Splunk on top of EMC gear around the world. So if you are a services deployer, you're a consultant who delivers Splunk, and are interested, please come find me. I'd love to talk with you about some of the things we're doing. Okay, and then check out our apps. So if you've got Splunk deployed in an account where you know there's some EMC kit on the floor that you'd like to Splunk, check out the apps. Again, they're free. If you have questions about them, the authors are right there in Splunk base. You can ping those folks directly. And then if you do have that customer who maybe is already running Splunk and EMC is the storage platform underneath it, if they're willing to do a quick data collection with me, I've got some real standard scripts that we use that their storage folks have probably already seen, and I will provide back a pretty interesting health report back to the customer on how the environment's running. Okay, and then just keep being awesome. All right, have some fun. I hope you all are enjoying Barcelona. And if anybody's sticking around, Thursday night is apparently going to be a giant party in town. So I'll be at the beach, hopefully without my hair on fire. So anyways, thank you very much for your time. Hope you all enjoyed it, guys.